Welcome to the Architect of a Dream channel. Today, we will embark on a quiet journey to the very edge of the visible world, to where light meets eternity. We will speak of the boundary of the universe, not as a wall or a limit, but as a horizon beyond which it is impossible to look. This is a journey not in space, but in time, to the very first moments of existence, whose echo still washes over our world. We will touch upon the mystery of what lies beyond our perception, where the laws of physics may be different, and the very concept of space loses its meaning. This is a lullaby about infinity, told in the language of stars. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. This helps others find their way here, one sleepy soul after another. And now, just breathe. Let your eyes grow heavy and your mind soften. Let us begin. Imagine a sphere of light, with you at its center. And this sphere is everything that ever was and ever will be accessible to your sight. This is not a physical boundary, but a limit of information, called the particle horizon. It exists for every observer, and each is at the center of their own visible world. Light from the most distant objects has traveled to us for almost 13.8 billion years, the entire lifetime of the universe. But in the time it was traveling, the very space between us and these ancient galaxies was expanding, like an invisible fabric. Therefore, we see them not where they are now, but where they were in the deep youth of the cosmos. This boundary is not a wall in space, but a wall in time, beyond which we cannot look, because beyond it lies the dawn of time, when light could not yet travel freely. This wall in time has a name, the recombination epoch, and it left behind the most ancient image known to us. This is the cosmic microwave background radiation, which envelops us from all sides. Imagine a fog that filled the entire universe in its infancy. Only when the universe had cooled enough, about 380,000 years after the Big Bang, did this fog dissipate, and light was able to embark on its free journey for the first time. What we see as the cosmic microwave background is the light of that very dawn. A light that has traveled to us for billions of years, and stretched along the way, cooled, turning into a barely perceptible microwave whisper. This is the oldest photograph of our world, an imprint of its childhood, uniformly distributed across the entire sky. This ancient whisper is not perfectly uniform. It has a barely noticeable ripple, tiny fluctuations in temperature. These fluctuations, amounting to only 100,000th of a degree, are the seeds of all the structure we see today. In these microscopic hot and cold spots on the map of the cosmic microwave background, the future galaxy clusters and the giant voids between them were laid down. The denser, slightly hotter regions became centers of gravity around which matter eventually gathered, forming stars, galaxies, and ourselves. We are the children of this primordial ripple, descendants of tiny imperfections in the perfectly smooth fabric of the newborn universe. Every galaxy, every star, is an embodied note from that ancient symphony of temperatures. These primordial notes did not just exist, they resonated, spreading through the young universe like waves in a pond. In the dense, hot plasma of the early cosmos, gravity pulled matter together, while radiation pressure pushed it back apart, creating giant sound waves. These waves, known as baryon acoustic oscillations, traveled through the plasma for 380,000 years. When the universe cooled and became transparent, these waves froze in place, leaving behind spherical shells of excess matter density. Today we see their imprint in the distribution of galaxies, which prefer to form at a specific distance from one another, corresponding to the radius of these ancient sound spheres. This is a kind of standard ruler, imprinted into the very fabric of the cosmos. This ancient light signature also holds more subtle patterns, accessible only to the most sensitive instruments. The light of the cosmic microwave background is polarized, its waves oscillating in specific directions. This polarization arose in the final moments before the light began its free journey, when photons last scattered off electrons. It carries information about the motion of the plasma at that moment, about the geometry of the universe, and even about events that occurred much earlier. By studying these polarization patterns, the so-called E modes and B modes, astrophysicists hope to find traces of primordial gravitational waves born in the fire of inflation. It is like trying to guess the nature of a storm that raged before winter by the ripples on the surface of a frozen lake. This symphony plays out against the backdrop of expanding space, which itself creates the very horizon of our vision. The expansion of the universe is not an explosion into existing space, but a stretching of the very fabric of space-time. Imagine the surface of an inflating balloon, on which dots representing galaxies are drawn. When you inflate the balloon, the distance between all of the dots increases, but the dots themselves are not moving across the surface. Similarly, galaxies are not flying through the cosmos, but are carried away from each other along with expanding space. And the farther a galaxy is from us, the faster it recedes. It is similar to how a river flows faster and faster, carrying distant ships away from us. Because of this accelerating flow of space, there comes a point when galaxies recede from us at a speed exceeding the speed of light. This does not violate the theory of relativity, as it is not the objects themselves moving faster than light, but the space between us that is expanding. Light from such galaxies, even if it is directed toward us, will never reach us. It is like a swimmer trying to swim against the current of a river whose speed is greater than their own. These galaxies disappear forever beyond our cosmic horizon, their light fading for us, turning into an eternal echo that we will never hear. We live in an era when the universe is slowly extinguishing its most distant lights for us. These fading lights make one wonder, what lies there beyond the horizon? The simplest and most elegant answer that cosmology offers is more of the universe, the very same one as ours. The cosmological principle states that on large scales, the universe is homogeneous and isotropic, meaning it looks approximately the same in all directions and from any point. This means that if we could instantly travel beyond our horizon, we would see nothing fundamentally new. We would find ourselves at the center of a new sphere of visibility, surrounded by the same galaxies, stars, and laws of physics. Our observable universe is just a tiny bubble in the boundless ocean of the cosmos, which extends far, perhaps infinitely, beyond our sight. This boundless ocean is possibly so vast that our observable universe, in comparison, is but a single atom. The inflationary model, which describes the first moments after the Big Bang, suggests that space expanded by an unimaginable amount in a tiny fraction of a second. This means that the actual size of the universe could be trillions of times larger than the part we can observe. We live on a small island of light in an ocean so vast that we can never see its shores. This is a humbling knowledge that turns our cosmos into a cozy home, surrounded by an incomprehensible, yet not hostile, infinity. This infinity can have different forms, different geometries. The fate and shape of the universe depend on its total density of energy and matter. If the density is greater than the critical density, the universe has a closed geometry, similar to the surface of a sphere. By traveling in one direction, you would eventually return to your starting point. Such a universe is finite, but has no edge. If the density is less than critical, the geometry is open, resembling the surface of a saddle, and it is infinite. And if the density is exactly equal to the critical density, then the universe is flat, like an infinite sheet of paper. Modern observations show that our universe is very, very close to being flat, which hints at its possible infinity. But even if reality is not a hologram, the connection to the past is felt everywhere. Every atom in your body, except for hydrogen and helium, was created in the core of a dying star that exploded billions of years ago, scattering these elements across the cosmos. We are made of stardust. Our solar system formed from a cloud of gas and dust, enriched with the remnants of previous generations of stars. We are not just observers of the universe. We are an integral part of it, its way of knowing itself. The boundary between us and the cosmos is conventional. We are a local complexification of the very same matter that forms distant galaxies at the edge of the visible world. Imagine this flat, infinite fabric of space that continues to expand forever. This is the most likely scenario for the future of our world. In it, galaxies will recede from each other ever faster under the influence of dark energy. In trillions of years, the sky for an observer in our galaxy will become completely black and empty. All other galaxies will have been carried beyond the event horizon, leaving us in complete isolation. Future civilizations, if they arise, will never know of the existence of other galaxies, of the Big Bang, or of the expansion of the universe. They will live in the eternal silence of an island world, unaware of the grand history that unfolded before them. This isolation is a natural consequence of the existence of dark energy, a mysterious force that causes space to expand at an accelerating rate. It constitutes almost 70% of all energy in the universe, yet we know almost nothing about it. It does not clump together like matter, but is uniformly distributed throughout the cosmos, like an invisible, repulsive field. Perhaps it is a property of the vacuum itself, an energy inherent to empty space. Its nature is one of the greatest mysteries of modern physics. And it is this that determines the ultimate fate of all existence, slowly pushing the boundaries of our world to complete emptiness. However, this all-determining entity is the source of the deepest crisis in modern physics. When we try to calculate the vacuum energy predicted by quantum field theory, we get a number that is 120 orders of magnitude, a 1 followed by 120 zeros, larger than the observed density of dark energy. This is the largest discrepancy between theory and experiment in the history of science. It means that either we fundamentally misunderstand something about gravity or quantum mechanics, or there is some unknown mechanism that almost completely cancels out this gigantic vacuum energy, leaving only the tiny remnant that we call dark energy. This tiny remnant decides the fate of everything, but its existence is a gaping wound in the body of our knowledge. This gaping wound compels physicists to search for alternative explanations. What if dark energy is not a constant property of the vacuum, but something dynamic? This idea has been named quintessence. after the fifth element of the ancient Greeks. Quintessence is a hypothetical field, similar to the electromagnetic field that permeates all of space. But unlike the cosmological constant, its density and pressure can change over time. It might have behaved differently in the past than it does now, and its future behavior is also unknown. Perhaps one day it will weaken, and the expansion will slow down, or perhaps, on the contrary, it will intensify its effect. This idea transforms dark energy from a mysterious constant into a living, evolving participant in the cosmic drama. This drama could lead to an even stranger finale than eternal expansion. There are theories of phantom energy, according to which the density of dark energy will not decrease over time, but instead grow. This would lead to a Big Rip scenario. First, the accelerating expansion will tear apart the gravitational bonds between galaxy clusters. Then, millions of years later, it will overcome the gravity within the galaxies themselves, and they will disintegrate. Then planets will begin to be torn from their stars, and in the final minutes before the end, matter itself will not hold. Planets, stars, and even people will be ripped apart. In the final fraction of a second, atoms and nuclei will be torn apart, and the very fabric of space-time will rip into infinity. The void between galaxies, however, is not absolute. It is permeated by giant, invisible filaments that form the so-called cosmic web. These filaments consist mainly of dark matter, another mysterious component of the universe. Ordinary matter from which stars and planets are made flows along these invisible filaments like rainwater down the threads of a spiderweb and accumulates at the nodes. It is in these nodes that giant clusters of galaxies form. We see only the glowing dewdrops on an invisible structure that forms the skeleton of the entire cosmos. The boundaries of our world are not only the horizon of light, but also the limits of our understanding of this invisible cosmic scaffolding. This invisible dark matter does not interact with light, so we cannot see it directly. We know of its existence only through its gravitational effect on visible objects. Galaxies rotate too quickly to be held together by visible matter alone. Something invisible and massive creates additional gravity, preventing them from flying apart. This something is dark matter. It is like a silent, invisible guardian that keeps the galactic carousels in balance, forming islands of light in an ocean of darkness. Its nature remains a mystery, another horizon for our knowledge. This mystery has given rise to a whole zoo of hypothetical particles, any of which could be that invisible guardian. The most popular candidates are WIMPs, or weakly interacting massive particles. They are thought to be heavy, yet interact very little with our ordinary matter, passing through us and the Earth like ghosts. Another idea is axions, incredibly light particles predicted to solve a problem in elementary particle physics. There are also more exotic hypotheses suggesting that dark matter is not particles but, for example, primordial black holes that formed in the first moments of the universe's life. The search for these particles is conducted deep underground, in giant detectors shielded from cosmic rays, in the hope of catching even a single rare moment of interaction between this ghostly matter and our own. And while direct searches have not yet been successful, we have a way to see the invisible by using the universe itself as a giant lens. According to Einstein's theory of relativity, massive objects warp space-time, and therefore the path of light rays. When light from a distant galaxy passes near a massive cluster containing dark matter, its path is distorted. We see this distant galaxy stretched into arcs, or even multiple images of it, as if looking at it through the bottom of a wineglass. By studying the degree of this distortion, this gravitational lensing, astronomers can create a precise map of the mass distribution in the cluster and see exactly where the invisible dark matter is hiding. The light of distant worlds outlines the contours of darkness for us. Perhaps the most striking proof of this invisible component's existence is the object known as the bullet cluster. This is the result of a collision between two giant galaxy clusters. When they passed through each other, the hot gas from the galaxies, which makes up most of the ordinary matter, collided and slowed down, remaining in the center. But the dark matter, which hardly interacts with itself, passed straight through without slowing down, outrunning the gas like two invisible bullets. Through gravitational lensing, we can see that the main mass of the clusters is located where the dark matter is, not where the visible gas is. This is a direct observation of the separation of the visible and the invisible, irrefutable evidence that most of the matter in the universe has a different ghostly nature. This ghostly nature, however, is not without its internal contradictions. The standard model of cold dark matter perfectly describes the universe on large scales, but runs into problems at the level of individual galaxies. It predicts that there should be very dense peaks of dark matter at the centers of galaxies, but observations show flatter distributions. It also predicts the existence of thousands of dwarf satellite galaxies around the Milky Way, but we see only a few dozen. These discrepancies are forcing scientists to either search for more complex models of dark matter or consider radical alternatives. One such radical alternative is the idea that dark matter does not exist at all. Instead, perhaps we misunderstand the laws of gravity. Theories of modified Newtonian dynamics, or MOND, suggest that at very low accelerations, typical of the outskirts of galaxies, gravity behaves differently than Einstein predicted. This change in the law could explain the rapid rotation of galaxies without invoking invisible mass. However, MOND struggles to explain phenomena at the level of galaxy clusters such as the bullet cluster, and does not explain the fluctuations in the cosmic microwave background. The mystery remains, and the frontier of our knowledge lies right between two possibilities. Either an invisible world exists, or the laws of nature are more complex than we thought. The boundaries of our knowledge are constantly expanding, much like the universe itself. What seemed like magic yesterday becomes understandable physics today. Perhaps dark matter and dark energy are simply manifestations of deeper laws of nature that we have yet to discover. Each solved mystery of the cosmos presents us with 10 new ones. It is an endless process of discovery, in which the horizon constantly recedes but never disappears. The very act of knowing, the drive to look beyond the edge of the known, is a fundamental property of our minds, reflecting the infinite nature of reality itself. But let's return to the edge of the visible world. What if the universe is, after all, finite? In that case, it might not have an edge in the usual sense. Imagine the surface of a giant four-dimensional sphere. To us, three-dimensional beings living on this surface, it would seem infinite, yet its volume would be finite. By traveling in a straight line, you would circumnavigate the entire universe and return to your starting point, just as Magellan circumnavigated the Earth. In such a universe, by looking through a powerful telescope in one direction, you could theoretically see the back of your own head. or more precisely, the light from our own galaxy having completed a round-the-world journey. This light, having completed a full journey across a closed universe, would be incredibly old and dim. It would show us our own galaxy in its distant past. This would create a bizarre cosmic mirror effect, where the sky would be filled with multiple ghostly images of the same galaxies at different stages of their evolution. So far, we do not observe such repeating patterns in the sky, which argues in favor of either a very large or an infinite universe. But the very thought of such a closed, self-contained cosmos, where all paths lead back home, possesses its own lulling poetry. The poetry of the cosmos also manifests in how we measure distances to its frontiers. One of the main tools are type Ia supernovae. These are explosions of white dwarfs that always occur with the same standard brightness. They serve as standard candles in the universe. Knowing their true brightness and measuring their apparent brightness, we can accurately calculate the distance to them and to their host galaxies. It was the observation of these distant cosmic beacons that allowed astronomers to discover that the expansion of the universe is accelerating. These flashes, marking the death of stars, have illuminated our path to understanding the fate of the entire cosmos. Besides these stellar explosions, there are other cosmic messengers whose flashes pierce the darkness. Gamma-ray bursts are the most powerful explosions in the universe since the Big Bang, capable of releasing more energy in a few seconds than our Sun will in its entire lifetime. They arise from the collapse of massive stars or the merger of neutron stars. These monstrous cataclysms are so bright that they can be seen from the other end of the observable world. They are the cries of newborn black holes, their echoes traveling to us across billions of years, carrying information about the most turbulent and violent processes in the cosmos. Each such burst is an instantaneous beacon, illuminating the deepest and most ancient corners of existence. And there are even more mysterious signals whose nature is still not clear. Fast radio bursts are intense but extremely short, millisecond-long pulses of radio waves coming from distant galaxies. Their source is one of the main mysteries of modern astrophysics. They could be magnetars, neutron stars with extremely strong magnetic fields, or something completely new and unexpected. These fleeting signals, like a cosmic Morse code, bring us news of the existence of objects and phenomena that we are only just beginning to imagine. They remind us that the universe is full of surprises, and the most important discoveries may still lie ahead. Joining these visible and radio messengers are the almost invisible phantoms, neutrinos. These elementary particles have almost no mass and interact extremely weakly with matter, which allows them to fly through stars and planets without noticing them. They are born in nuclear reactions in the hearts of stars, in supernova explosions, and in other cataclysms. Neutrino detectors, located deep underground or in the ice of Antarctica, catch these phantom particles, opening a window for us into the very depths of cosmic objects where light cannot penetrate. Neutrinos carry information directly from the fiery core of our Sun, or from the epicenter of a cosmic catastrophe that occurred millions of years ago, bringing us news from the most hidden corners of the universe. The light from these flashes, like any other light from deep space, is subject to cosmological redshift. As space expands, light waves are stretched, their wavelength increases, and they shift to the red, longer wavelength part of the spectrum. This is not the Doppler effect, which is related to movement through space, but an effect of expanding space itself. Redshift is the universe's clock, showing how long the light has been traveling and how much the cosmos has grown in that time. The most distant objects at the edge of our horizon have the largest redshift. Their light is so stretched that it has turned from visible light into infrared or even radio waves. At the very edge of the visible universe, the redshift becomes infinite. Light from objects located right on the particle horizon is stretched to an infinite wavelength, its energy dropping to zero. We will never be able to see what lies at this boundary, because the light from there simply lacks the energy to be detected. This is the absolute limit of visibility, beyond which lies a region from which information physically cannot reach us. It is like a sound that fades with distance until it dissolves into complete silence. The edge of our world is the place where the cosmic song fades into eternal silence. This eternal silence makes us ask the question again: what if the laws of physics are different beyond the horizon? The theory of eternal inflation suggests that our universe is just one of many bubbles, born in a perpetually expanding metaspace, or multiverse. At the moment of its birth, each such bubble universe acquires its own random set of physical constants. In one world, gravity might be stronger, in another weaker. In most such worlds, the conditions would be unsuitable for the emergence of life. We live in one of those rare universes where the constants are luckily fine-tuned for our existence. This idea of a multiverse turns the edge of our universe into a boundary between bubbles. Perhaps beyond our horizon, another universe with different laws begins. We will never be able to verify this, as the space between these bubbles is expanding faster than the speed of light. This makes the multiverse more of a philosophical concept than a scientific theory in the strict sense. But it offers an elegant solution to the question of our world's fine-tuning. We exist here not because the universe was created for us, but because we could only have arisen in a universe like ours. Imagine an infinite ocean of boiling foam, where each bubble is a separate universe. Some bubbles burst quickly, others expand forever. Our world is just one such bubble, and we live on its inner surface. The particle horizon in this case is simply the limit of visibility within our own bubble. We will never see the other bubbles, never know what is happening inside them. We are locked in our cozy corner of the cosmos, but the very thought of the existence of other worlds, other possibilities, fills the night sky with a new, deeper meaning. Even if the idea of the multiverse is incorrect, the very infinity of our own universe gives rise to astonishing consequences. In an infinite space with a finite number of particle types and configurations, any possible combination must repeat. This means that somewhere out there, far beyond our horizon, there exists an exact copy of you, listening to this text, and not just one, but an infinite number of them. There also exists an infinite number of worlds where you made different decisions at key moments in your life. All possible histories are playing out somewhere in the infinite expanses of the cosmos. This is a statistical immortality, born from pure mathematics and infinity. This thought blurs the line between the unique and the repeating, turning our life into one of infinite variations on a given theme. This may seem frightening, but there is also a comfort in it. Every mistake, every missed opportunity has been corrected or realized somewhere else. The universe, in its infinity, explores all possible paths. Our horizon hides from us not only other galaxies, but also other versions of our own reality. scattered across the boundless fabric of space-time. This fabric of space-time is itself a dynamic entity. According to Einstein's general theory of relativity, matter and energy curve space-time, and this curvature is what we perceive as gravity. Black holes are an extreme case of this curvature, where space-time is so distorted that not even light can escape it. The event horizon of a black hole is a local boundary, a point of no return, very similar in its nature to the cosmological horizon. In both cases, we encounter a limit beyond which information cannot get out. By studying black holes, we can better understand the nature of boundaries in the cosmos. Stephen Hawking proposed that black holes are not, in fact, completely black. Due to quantum effects at the very event horizon, they slowly evaporate, emitting radiation named after him. This means that information that has fallen into a black hole might not disappear without a trace, but slowly seeps back out in an altered form. This offers hope that the cosmological horizon is not an absolute wall either, but rather a semi-permeable membrane through which the universe's past continues to influence its present. This information loss problem gave rise to another revolutionary idea, the holographic principle. It suggests that all the information contained within a certain volume of space can be fully described on the boundary of that volume, just as a three-dimensional image, a hologram, is encoded on a two-dimensional surface. If this principle holds true for the entire universe, then our three-dimensional reality might be merely a holographic projection of information stored on a two-dimensional boundary, on our cosmological horizon. We may be shadows cast on a cave wall, unaware of the real world unfolding at its entrance. This idea erases the fundamental distinction between boundary and content, between surface and volume. The edge of the universe ceases to be merely a limit of visibility and becomes the true carrier of all reality. Everything we see and feel, stars, galaxies, space and time itself, may be just a complex pattern inscribed on a distant horizon. This thought overturns our intuitive understanding of the world, turning the cosmos into a gigantic illusion, which nevertheless is our only reality. And we, as part of this hologram, are trying to decipher the laws by which it was created. This edge of the visible world, the particle horizon, is not static. It is constantly expanding. Every second, light from more and more distant objects reaches us, and our visible world becomes a little larger. We see increasingly younger regions of the universe. It is like slowly climbing a mountain, where with each step our horizon recedes, revealing new valleys and rivers. We live in a unique time when we can still see the light from billions of other galaxies. But this process will not be eternal. The accelerated expansion of the universe, caused by dark energy, will ultimately prevail. A moment will come when our horizon will begin to shrink. Not because the universe will become smaller, but because the light from new, more distant galaxies will no longer be able to catch up to us due to the too rapid expansion of space. Our visible world will begin to empty. Galaxies, one by one, will disappear beyond the horizon, like extinguishing candles. In the distant future, our Milky Way and its closest neighbors, bound by gravity, will remain the only island of matter in an infinitely expanding void. This picture of the future, known as the heat death of the universe, is filled with a quiet melancholy. All stars will eventually burn out. Black holes will slowly evaporate. The universe will turn into a cold, dark and almost empty soup of elementary particles, where nothing will ever happen again. This is a state of maximum entropy, of final equilibrium. But this future is so far from us that the human mind is incapable of comprehending it. We have trillions of years ahead of us before the last star goes out. Our task is not to fear this distant night, but to appreciate the light we see now. But the fading of the last star is only the beginning of true eternity, the onset of the degenerate era. The universe will be filled with the cooled corpses of stars, black dwarfs, neutron stars, and black holes. In this cosmic night, lasting for trillions of years, gravity will continue its unhurried work. Sometimes two degenerate stars will collide, generating a brief supernova flash in the pitch-black darkness. Planetary systems will slowly disintegrate, and the stellar remnants themselves will be gradually ejected from dying galaxies into the intergalactic void. Time will stretch to such an extent that events we consider impossible will become inevitable. It will be a world of shadows and gravitational whispers. This world of shadows may not be eternal if certain grand unification theories that predict proton decay are correct. According to them, even the building blocks of matter are not absolutely stable and must, over time, decay into lighter particles such as photons and leptons. The half-life of a proton is unimaginably long, perhaps 10 to the 36th power years or more, but on the scale of eternity, it is a finite number. This means that over time, all baryonic matter, all black dwarfs and neutron stars, all cooled planets and rocks, will slowly, atom by atom, dissolve into faint radiation. Everything that seemed solid and eternal will evaporate like a dream at dawn, leaving behind only energy. When the last proton decays, the black hole era will begin. They will become the only macroscopic objects in the universe. The giant black holes at the centers of former galaxies will slowly accrete the scattered matter and radiation, growing even more massive. The universe will become their undivided kingdom. For an unimaginable length of time, from 10 to the 40th to 10 to the 100th power years, these silent leviathans will be the sole keepers of information and complexity in the emptying cosmos. They will be the last islands of order in an ocean of increasing entropy, the last monuments to the stellar age. But even the reign of black holes is not eternal. Thanks to a quantum phenomenon discovered by Stephen Hawking, they too slowly evaporate, emitting faint thermal radiation. The more massive a black hole is, the slower it evaporates. But over time, after Google's 10 to the 100th power of years, even the most supermassive black holes will emit their last particle and disappear in a silent flash. And then the final, eternal phase will arrive, the dark era. The universe will become an almost completely empty, cold, and dark place. A vast expanding soup of photons, neutrinos, and other elementary particles with enormous wavelengths. This will be the true heat death, the final equilibrium, where nothing can ever happen again. It is the silence after all music has ended. This light that we cherish carries information not only about distance, but also about the composition of distant worlds. By analyzing the spectrum of light from stars and galaxies, we can determine what chemical elements they are made of. And we discover that the same laws of chemistry and physics operate everywhere in the universe. The elements we find on Earth are also present in the most distant quasars at the edge of the visible world. This confirms the cosmological principle and gives a sense of the profound unity of all that exists. The universe speaks one language, and we are slowly learning to understand it. Understanding this language allows us to reconstruct the history of the universe with astonishing accuracy. We can trace its evolution from the first microseconds after the Big Bang, through the formation of the first stars and galaxies, to the present day. We understand how complex structure emerged from primordial chaos. This history, written in the light of stars and the cosmic microwave background, is the greatest epic imaginable. And we, having appeared on one of its later pages, have been given the opportunity to read it from the very beginning. The beginning of this story, the very moment of the Big Bang, is hidden from us by another boundary, the Planck epoch. In the very first 10 to the power of -43 seconds, the density and temperature were so high that our modern theories of physics, including general relativity and quantum mechanics, ceased to work. Space and time as we understand them did not yet exist. This is an absolute horizon of knowledge, beyond which lies a realm requiring a new, unified theory of quantum gravity. What was before the Big Bang, or what caused it? These are questions that lie beyond this fundamental wall. This wall forces physicists to seek new ideas, such as string theory or loop quantum gravity. These theories attempt to describe reality at the most fundamental level, where space and time may not be smooth and continuous, but composed of tiny quantum atoms. Perhaps the Big Bang was not the beginning of everything, but a transition from another state, for example, a bounce from the collapse of a previous universe. The boundary of our knowledge here becomes a stimulus for the boldest flights of imagination, where science touches upon philosophy. One of the most beautiful ideas born at the intersection of these theories is the model of a cyclical universe. In it, the Big Bang is not a unique event, but just one episode in an endless chain of births and deaths. Our universe is expanding and cooling, but in the distant future, dark energy may weaken and be replaced by attraction, which will lead to a big crunch. The universe will collapse into a hot and dense point, but not into a singularity, but into a state from which it will bounce, giving rise to a new Big Bang. In this scenario, the edge of our time is merely an inflection point in an eternal cosmic breath, an inhalation and exhalation lasting trillions of years. Our world is but one wave in an infinite ocean of time. The philosophical aspect of the universe's boundary lies in its influence on our self-perception. The realization that we live on a tiny planet, orbiting an unremarkable star in one of hundreds of billions of galaxies, each containing hundreds of billions of stars, can evoke a feeling of insignificance. But it can also evoke a sense of wonder. In this vastness, life has arisen that is capable of comprehending this vastness. The universe, through us, looks at itself. Our fragility and finiteness against the backdrop of cosmic eternity make our existence all the more precious. The preciousness of the moment is emphasized by the fact that we live in a cosmological spring. The universe is still young and dense enough for us to observe its rich history. In the distant future, when the galaxies fly apart and the stars die out, the cosmos will become a much less interesting place to study. We live in a golden age of cosmology, when the sky is still full of stories that can be read. Our horizon is still filled with the light of ancient worlds, and we must appreciate this opportunity, this fleeting gift. This gift is the ability to see the past. When we look at the Andromeda Galaxy, we see it as it was 2.5 million years ago. When we look at quasars at the edge of the visible universe, we see their light, emitted more than 10 billion years ago, when the universe was very young. The entire sky is a time machine directed into the past, and the farther we look, the deeper into history we delve. The edge of the visible world is not just a spatial boundary. It is a boundary of time, beyond which lies the dawn of creation. This dawn of creation, the recombination epoch, is visible to us as a smooth wall of light. But what if we could look behind it? We would see an opaque, turbulent plasma, where light could not travel freely, constantly scattering off free electrons and protons. It would be a dazzling, uniform veil, devoid of any structures. The universe up to that point was like the interior of a star. Only its cooling allowed the hydrogen atom to form and make the cosmos transparent. Our world was born the moment it learned to let light pass through. The transparency of the world allowed gravity to begin its slow work of forming structures. The first stars, which ignited several 100 million years after the Big Bang, were giants, hundreds of times more massive than the Sun. They lived fast and died young, exploding as supernovae and seeding the cosmos with the first heavy elements. These titan stars were the pioneers that prepared the ground for subsequent generations of stars and planets, including our own. Their light has long since faded, but their legacy lives on in each of us. We are the children of these first furious suns. The search for light from these very first stars, the so-called population 3 stars, is one of the main objectives of modern astronomy. They are so far away, at the very edge of our temporal horizon, that their light is incredibly faint and redshifted into the infrared part of the spectrum. Telescopes like the James Webb are specially designed to peer into this pre-dawn gloom and try to catch the first photons emitted by the first stars. To find them is to see the moment when the universe first lit its own fires after the long era of the Dark Ages. These Dark Ages are the period between the dissipation of the primordial fog and the ignition of the first stars. The universe was transparent, but dark, filled only with hydrogen, helium, and invisible dark matter. It was an era of silence and waiting, as gravity slowly pulled matter into clumps that eventually reached a critical density and erupted in nuclear fire. This process was named reionization, as the intense radiation from the first stars and quasars reionized the neutral hydrogen that filled the cosmos. The universe once again became like a fog, but this time not a solid one, but patchy, pierced by light. This dawn was uneven. The first galaxies were small and irregularly shaped. They constantly collided and merged with each other, forming ever larger structures. Our Milky Way galaxy is the result of countless such mergers over billions of years. It still continues to absorb smaller dwarf galaxies that fall into its gravitational field. This process of cosmic cannibalism is the primary mechanism of galaxy growth. The universe is not static. It lives, breathes, and evolves. The evolution of the universe is recorded in the distribution of galaxies in space. They are not scattered chaotically, but form gigantic walls, filaments, and clusters separated by vast voids. This structure resembles a giant sponge or a neural network. The largest of these voids stretch for hundreds of millions of light-years and are almost devoid of any matter. They are the quietest and loneliest places in the universe. The boundary between a dense populated region and this void is as real as a coastline. One such anomaly is the Eridanus supervoid, or the CMB cold spot. This is an unusually large and cold region on the map of the microwave background. One hypothesis states that this is the imprint of a giant supervoid located between us and the surface of last scattering. As photons of the cosmic microwave background pass through this void, they lose a bit of energy, which makes this region colder. It's as if we were looking at a distant landscape through a cold pane of glass. These voids are scars on the face of the universe, reminders of its turbulent youth. By studying these scars and structures, we are trying to understand the initial conditions that gave rise to them. The inflationary theory suggests that the entire structure of the universe was born from microscopic quantum fluctuations in the first moments of its existence. These fluctuations were stretched to astronomical sizes during inflationary expansion. This means that the largest structures in the cosmos are quantum uncertainties magnified to unimaginable scales. The macrocosm is a direct reflection of the microcosm. This deep connection between the very large and the very small is one of the most beautiful ideas in modern physics. To understand the edge of the universe, we need to understand the laws governing subatomic particles. To understand the nature of particles, we need to study the universe at its largest scales. Cosmology and particle physics are two sides of the same coin, two keys to the same door, behind which lie the fundamental laws of nature. This door may lead to an understanding of why anything exists at all. Why does matter exist? According to the Standard Model, in the early universe, matter and antimatter should have been created in equal amounts and completely annihilated each other, leaving behind only an ocean of light. But this did not happen. For every billion particle-antiparticle pairs, there was one extra particle of matter. It is from this tiny excess, from this fundamental asymmetry, that everything we see around us is made, stars, planets, and ourselves. We are the remnant of the Great Annihilation, a rounding error in the cosmic equation. This tiny asymmetry is another frontier of our understanding. We do not know exactly why it arose. Perhaps it is related to the properties of neutrinos, or the existence of yet undiscovered particles. But whatever the reason, it is this asymmetry that separates our world from a world of absolute emptiness and light. The edge of the universe, therefore, is not only the limit of visibility, but also the fine line between being and non-being, on which our world has been balancing since its very birth. The idea of balance permeates all of cosmology. The universe exists thanks to a delicate balance of fundamental constants. If gravity were slightly stronger, the universe would have collapsed back into a point shortly after the Big Bang. If it were slightly weaker, stars and galaxies would never have formed. If the force holding atomic nuclei together were different, carbon, and therefore life, would not exist. This list could go on forever. Our universe seems to be incredibly finely tuned for the existence of complexity and life. This fine-tuning can be explained by the anthropic principle, which in its weak form states that we observe the universe as it is because only in such a universe could observers have emerged. This is not an explanation, but rather a statement of fact. In its strong form, it suggests that the universe had to have such properties for life to arise at a certain stage of its evolution. This brings us back to the idea of a multiverse, where there is an infinite number of universes with different properties, and we simply live in one of the hospitable ones. But even in our hospitable universe, life is a rare and fragile phenomenon. The Fermi paradox asks, if the universe is so vast and old, why do we not see any signs of other intelligent civilizations? Perhaps life is rare. Perhaps intelligent life self-destructs. Or perhaps they are simply too far away beyond our event horizon, and their signals will never reach us. The universe may be full of life, but we are doomed to solitude due to vast distances and the finite speed of light. Our horizon is also a wall, separating us from possible cosmic neighbors. This wall of silence makes the sound of humanity, our radio signals flying into space, particularly poignant. The sphere of our transmissions, expanding at the speed of light, has already reached thousands of nearby stars. But compared to the size of the galaxy, this is a tiny bubble. And even if someone out there hears our first television broadcasts, a reply will arrive in hundreds or thousands of years. Dialogue at such distances is impossible. We can only send our messages into the void, like notes in a bottle, cast into a boundless ocean. This ocean is perhaps not as empty as it seems. There is the dark forest hypothesis. The universe is full of civilizations, but they all remain silent and hide because they are afraid of attracting the attention of more advanced and potentially hostile predators. In such a scenario, anyone who sends a signal risks being destroyed. The silence in space is not a sign of the absence of life, but a sign of universal fear. This is a grim but logical possibility that turns our horizon into a veil concealing an unseen and dangerous life. But let us return to more tranquil thoughts. The boundary of the visible world is not only a physical, but also a psychological phenomenon. It is defined by our ability to perceive and interpret information. With each new telescope, with each new theory, we push this horizon back a little. It is not set in stone. It is malleable and depends on our curiosity. The edge of the universe is a challenge to our intellect and imagination. Imagination allows us to build models of what might lie beyond visibility. We can imagine a fractal universe where the structure of galaxy clusters repeats on ever larger scales to infinity. We can imagine a cyclical universe which undergoes an endless series of big bangs and big crunches, like a cosmic heartbeat. These ideas go beyond verifiable science, but they nourish our spirit of exploration. By exploring the edge of the universe, we are in fact exploring ourselves. We project onto this final frontier our hopes, fears, and questions about the meaning of our existence. Is the universe meaningful or absurd? Friendly or indifferent? Finite or infinite? We seek the answers to these questions not only in telescope data, but also in the depths of our own consciousness. The cosmos is a mirror in which we see the reflection of our own soul. This mirror shows us that we are made of the same substance as the stars, that we obey the same laws as distant galaxies, that our short life is a part of a grand cosmic history. Realizing this fact can bring a deep sense of belonging and peace. We are not strangers in this world. We are its legitimate children. And the boundary of our world is not a prison wall, but a horizon line that beckons us forward, toward new discoveries and new understanding. Understanding that our visible world is just a small part of the whole teaches humility. Our problems, our conflicts, our ambitions seem insignificant on a cosmic scale. This does not devalue our lives, but on the contrary, gives them a new perspective. It allows us to let go of petty anxieties and focus on what is truly important: love, knowledge, and the contemplation of beauty. A beauty that is diffused everywhere, from the pattern of a snowflake to the structure of the cosmic web. This cosmic web, with its filaments and voids, is the largest structure in the universe. But how did it appear? The answer again lies in the first moments after the Big Bang. Quantum fluctuations in the primordial inflaton field created tiny differences in density. Gravity amplified these differences. Denser regions attracted more matter, becoming even denser, while less dense regions became increasingly empty. Thus, from almost perfect uniformity, the complex and beautiful structure we observe today was born. Today, we can create three-dimensional maps of this structure, plotting the positions of millions of galaxies on them. These maps show that galaxies are not distributed uniformly, but are gathered into enormous walls and filaments. One of the largest such structures is the Sloan Great Wall, stretching for more than 1 billion light-years. Our own Milky Way galaxy is located in a relatively quiet and sparsely populated region, on the outskirts of the giant Virgo cluster, which in turn is part of an even larger structure, the Laniakea supercluster. Laniakea, which translates from Hawaiian as immeasurable heavens, is a gigantic structure containing about 100,000 galaxies, bound by a common gravitational pull. They are all moving toward a single point, the Great Attractor, a massive gravitational anomaly hidden from us by the dust of the Milky Way. We live in this giant celestial river, slowly flowing along with thousands of other galaxies toward an unknown center of gravity. Our home is not just a planet or a galaxy, but an entire continent of galaxies, drifting in a cosmic ocean. This drift toward the Great Attractor is only part of the overall motion. The Laniakea supercluster itself, like other similar structures, is moving relative to the cosmic microwave background radiation. This motion, called the dark flow, indicates the possible influence of gravity from structures located beyond our visible horizon. This is one of the few pieces of indirect evidence that matter exists there, beyond the edge influencing our world. The horizon is not an impenetrable wall. It allows gravitational drafts from the unknowable to pass through. These drafts remind us that we are part of something larger. Our visible universe is not an isolated system. It interacts with what lies beyond its borders, even if we cannot see it. This is similar to how island inhabitants might surmise the existence of a large mainland from arriving birds or logs washed ashore. Gravity is our bird, our log, brought from beyond the horizon. The horizon also changes depending on how we define it. The particle horizon is the limit of what we can see. But there is another horizon, the event horizon. This is the boundary beyond which events happening now we will never see due to the accelerated expansion of the universe. Objects crossing this horizon disappear forever from our causal connection. Over time, as the expansion accelerates, this horizon will draw ever closer to us, enclosing us in a constantly shrinking bubble of accessible information. Inside this bubble, history will continue. Stars will be born and die. Perhaps new forms of life will emerge. But the connection to the greater cosmos will be lost. Future inhabitants of our local group of galaxies will look at the sky and see only emptiness. They may never learn about the Big Bang, the cosmic microwave background, or the cosmic web. The knowledge we have today is a unique window into history that will eventually close. This makes us appreciate the present moment even more. We live in a privileged era when we can simultaneously see both the universe's past in the form of distant galaxies and its future in the form of accelerating expansion. We stand on a hilltop with a view of the entire temporal panorama of the cosmos, but this hill is slowly sinking into fog. Whatever the ultimate fate may be, it will unfold on timescales that make a human life an instant. But in this instant, we are capable of asking these great questions. The ability to ask the question, what is out there beyond the edge, is perhaps more important than the answer itself. It is the engine of our development, the source of our art, science, and philosophy. The philosophy of the edge teaches us to accept uncertainty. We live in a world where fundamental questions may not have answers available to us. We must learn to live with mystery, without trying to fill it with dogmas. Mystery is not a void to be filled, but a space in which imagination and humility can grow. Humility in the face of the cosmos is not defeat, but wisdom. It is an understanding of our place in the grand scheme of things. We are fleeting patterns on the surface of a boundless ocean. But while we exist, we can reflect the light of the stars within ourselves and try to understand the nature of the waves that gave birth to us. These waves are gravitational waves, ripples in the very fabric of space-time predicted by Einstein. When massive objects, such as black holes or neutron stars, collide, they create these waves that propagate through the universe at the speed of light. Recently, we have learned to detect them. This has opened a completely new window into the universe. Now we can not only see the cosmos, but also hear its most dramatic events. Gravitational waves can carry information from regions hidden from us by light. For example, from the very first moments after the Big Bang. Primordial gravitational waves, born during inflation, should still permeate the universe. Their detection would be direct proof of inflationary theory, and would allow us to look beyond the wall of the cosmic microwave background, to hear the echo of the very birth of time and space. This is the next horizon we are trying to overcome. Overcoming one horizon after another, we expand not only our knowledge, but also our consciousness. We learn to think on scales of billions of years and billions of light years. We begin to feel ourselves not as citizens of a country or a planet, but as citizens of the cosmos. This cosmic perspective can help us overcome our terrestrial disagreements and see all of humanity as a single crew of a small ship sailing through eternity. This ship, Earth, is our only home. Studying the distant boundaries of the universe reminds us of its uniqueness and fragility. There are trillions of planets in the observable universe, but we have not yet found a single one like ours. This makes protecting our world our primary and sacred duty. The cosmos is vast, but we have only one home, and yet the thought of other homes, other worlds, does not leave us. Perhaps somewhere beyond the horizon, in another galaxy, on another planet, someone else is looking at the sky and asking the very same questions. Perhaps our thoughts, separated by an abyss of space and time, meet somewhere in the common informational field of the universe. This thought of an invisible connection, of a universal community of thinkers, may be the most comforting discovery we make while looking at the edge of the world. The edge of the world is not the end. It is the beginning of mystery, the beginning of imagination, the beginning of an endless journey of discovery. It is the line where the known meets the unknown, and in this contact, a miracle is born. It is a boundary that defines us, compelling us to constantly reach beyond its limits. This limit exists not only outside, but also inside us. The boundary between consciousness and subconsciousness, between knowledge and faith, between wakefulness and sleep. Every night as we fall asleep, we cross our own event horizon, plunging into a world where the laws of logic give way to the laws of dreams. This journey is as mysterious and fascinating as the journey to the edge of the universe. And in this inner cosmos, we can also find a reflection of the outer one. An infinity of possibilities, hidden structures, sudden insights. Perhaps the universe is fractal, not only in space, but also in its nature. And the structure of our mind repeats the structure of the cosmos. We are a microcosm containing a reflection of the macrocosm. So, what is the boundary of the universe? It may be just an illusion, generated by our finite speed of perception in an infinite world. It may be a real wall, separating our bubble from other worlds. It may be a turning point in an eternal cycle. Or most likely, it is simply a horizon that will forever recede as we walk towards it, luring us further and further into the depths of being. This depth does not frighten, but pacifies. The realization that we are part of something so grandiose and incomprehensible relieves us of the burden of omniscience. We do not need to know all the answers. It is enough to simply be here and now, to breathe, to feel, and to wonder. To wonder at the fact that we exist, and can contemplate this quiet, majestic picture. This picture is painted with light and darkness, matter and void. Each of its elements plays its role. Dark matter builds invisible scaffolding. Dark energy pushes galaxies apart. Light brings us news from the past. And we, creatures born of stardust on a small planet, try to read this cosmic canvas. This canvas is constantly changing. Every second, a supernova explodes somewhere, a new star is born, galaxies collide. The universe lives its own, unhurried life. Our horizon is just a snapshot in this endless film. We see only a single frame, but we can imagine the entire movie. Imagining this movie, we understand that the end of one story is the beginning of another. The death of a star gives life to planets. The collision of galaxies creates new generations of stars. Perhaps the end of our universe, whatever it may be, will become the beginning of something new, something we cannot even imagine. Life and death in space are not opposites, but parts of a single cycle. This cycle is also reflected in our breath. Inhale and exhale, expansion and contraction. Each inhale fills us with energy. Each exhale releases tension. Allow your breath to become the rhythm of the universe. Feel how with each inhale, you draw in a particle of the cosmos, and with each exhale, you dissolve into its infinity. This infinity is not cold or hostile. It is filled with potential. In every cubic centimeter of vacuum, hidden energy seethes, virtual particles are born and disappear. The void is not empty. It is the cradle of all that exists. And our world, our visible island, is just one of the waves that have risen on the surface of this quantum ocean. This ocean has no shores, and the journey to its horizon is a journey without end. But the goal of this journey is not to reach a destination, but to enjoy the process itself, to enjoy the silence, the beauty, and the mystery, to let this mystery lull your mind like a quiet lullaby, a lullaby about how you are a part of this miracle, that every atom of yours remembers the light of the first stars, that your consciousness is the most amazing phenomenon in the entire visible universe, that the boundary of the world does not lie somewhere out there, billions of light years away from us, but right here, on the tips of your eyelashes, which are slowly closing. Beyond this boundary begins your own cosmos, a world of dreams, where there are no laws of physics and no limits to imagination. Allow yourself to plunge into it. Let go of thoughts about the edge of the universe, and feel yourself at its center. the center of your own quiet, sleeping world. This world is safe and calm. There is no accelerating expansion and no black holes here. Here, there is only peace and silence. A silence filled with the echo of distant stars and the promise of a new day. Let this silence envelop you like a warm blanket. The horizon of your consciousness slowly dissolves. Thoughts become light, like clouds of interstellar dust. The body becomes heavy and relaxed, pulled by the soft gravity of your bed. You are drifting in a warm and safe space, on the border between wakefulness and sleep. This border is the coziest place in the universe. Here, all questions find their answers in the silence. Here, all anxieties dissolve in peace. Here, you can just be, just breathe, just sleep, and may the light of the most distant galaxies, which travelled for billions of years to reach us, be the last image you carry with you into sleep. A light that has seen the birth and death of worlds, and which now gently touches your closed face, wishing you a good night. You are at the center of your own universe, and its only boundary now is the soft line separating the last waking moment from deep, restorative sleep. Cross it without fear. Peace awaits you beyond it. And as you sink deeper and deeper, remember that even in the deepest darkness of the cosmos, there is light. And even in the most profound silence, there is music, and you are a part of that light and that music. You always have been and always will be. The horizon has been crossed. The journey into sleep has begun. The universe will be waiting for you here when you return. For now, rest, just rest. We stood on the shore of the cosmic ocean, gazing at the horizon line, beyond which infinity is hidden. We tried to understand if this ocean had an edge, and we realized that the shore itself is merely a reflection of our own gaze. The boundary of the universe turned out to be not a wall, but a mirror in which we see the limits of our knowledge and the boundlessness of our imagination. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. And now, just breathe. Allow your eyes to grow heavy, and let the quiet horizons of the universe lull your thoughts. Good night.